Hello everyone, welcome back to the channel. So today we'll look at one of the most prominent concepts of physics, that is the projectile motion. So let's start with the basic introduction of the projectile motion. So what is projectile? So projectile is just an object moving under the action or influence of gravity. So like we throw something, then it gets attracted to the earth. That is gravity, and that object moving under the action of gravity is just a projectile. Now, under projectile, we have trajectory. Now, what is trajectory? It is just the path covered by the projectile. All right. And another important term is the range of projectile. It is a very simple term which means the horizontal distance covered by a projectile. So there are certain types of projectile. For example, horizontal projectile, projectile, and many more. What we are looking at prominently in this video is horizontal projectile and parabolic projectile. So, horizontal projectile. Now, horizontal projectile is nothing but suppose someone is standing on a cliff, a man is standing on a cliff, and he throws a ball maybe from this height edge down. So, this entire thing is a horizontal projectile. He's just throwing it uh, down at certain angle. There's some angle theta. All right. So suppose this at an angle of theta. Now, now we know that what is a horizontal projectile. Now to derive some equations from this horizontal projectile, so we can just make a diagram of horizontal projectile like this. H ball thrown down. Yes, the angle may or may not be there. In most of the cases, as you will see in the questions, there are no angles given because it is there's no angle with which it is thrown, since there's just horizontal velocity which is acting downwards. There is no vertical velocity which acts in horizontal projectile. So now we take two now we divide a projectile into two directions, like along x-axis, along x, and along y. All right, now let's take along x. Now along x, our object is thrown with velocity of u. So the initial velocity of a projectile is u, yes, and the acceleration is not there along the horizontal axis, yes. So acceleration along x is zero. While if we talk about the y-axis, there's no initial velocity which is acting, yes. So initial velocity is zero, and there's an acceleration which is acting downwards, and that is minus g, or minus 9.8 meter per second square. All right. Now using a Suvat equations. Now we know that we have four Suvat equations, and let me write it around here. Oh, wait, let me just write it here. Suvat equations of motion. First one is v is equals to u plus 80. Second is v square is equals to u square plus 2as. Third one is s is equals to ut plus half at square, and fourth one is s is equals to v plus u by 2 multiplied by t. Now we'll use these equations throughout a projectile, so make sure that you remember all of these equations and doesn't face any problem while derivations. Okay, so in this, along the x-axis, we'll use the first equation. So v along x is equals to u along x plus at. Now acceleration is zero, so v along x is equal to u along x. Now v along y is equals to u along y plus at, and a is minus g. So vy is equals to u along y minus gt. Now u along y is 0, as we know that there is no initial velocity acting along the y direction. So vy just becomes minus gt. Now we know the velocities of them. To derive the distance covered, so Sx is equals to uxt plus half at square. Again, acceleration is 0. So distance covered along x is speed into time. This is just distance is equal to speed into time. Remember it like this. And in along the y direction, what is the height? We took the height as u along y into t plus half at square. A is minus g, and u along y is 0. So sh becomes minus half gt square. And remember that you have to always divide into components for better calculations of the projectile. Now, proceeding further, if we need to find the time for this, we'll use the y direction for finding the time. Although time remains same for both. You know that there's nothing like time is different for this and different for this. No. So from this height, we can take the time. And time is not neither positive nor negative, so we can just write h is gt square by 2. So t square is equals to 2h by g. So t is equals to root 2h by g. And make sure that g you have to take as per 9.8 or 10, whatever is mentioned in the question. Most of the case you have to take it as 9.8. And that is how we derive everything from a horizontal projectile. Okay, I've circled all the things, you can see, look at it once. Now we'll proceed to parabolic projectile. Okay, so second one is parabolic projectile. Now what do you get by parabola? Something like downward parabola, upward parabola, something like this. Yes. So we'll take the this kind of parabola. Suppose a man is standing here. He throws a ball or an object at at like this, at certain angle. So now we need to calculate the distance, the time taken, and the height till which it reaches. So for that, let's make a formal diagram for this. Suppose this is an object which is thrown at an angle of theta with speed of u. So this goes like this. Yes. Now for from this, what we get is we have u at this thing. Now we'll resolve it into two things, like resolve it into two directions, x and y. Suppose u y, and this is u x. We resolve this because we didn't have any definite axis of u of the initial velocity, right? And if you have if you have prior knowledge of vectors, then you might know that when we resolve vectors, the base of the angle with which the x velocity is there is it becomes u, yeah, ux becomes u cos theta, while velocity along u direction becomes u sine theta. This is how we resolve the vectors, right? Now we divide into two components again. So along x and along y. Again, we need to keep the SUAT equations in the mind. Wait, let's take this. Let's copy it here. Yeah, just a minute. Yeah, so let's bring the SUAT equations here. Now, along the x direction, now let's see what is happening actually, what is happening here. So, along x direction, we have initial velocity as u cos theta, while along y direction we have u sine theta as we resolve the vectors. Now acceleration along x direction is again 0 because there's no acceleration acting, yeah. And acceleration along y axis is minus g, which is just minus 9.8 meter per second square. Now proceeding further, let's take the first wet equation again. Now velocity along x is equals to the initial velocity against x plus axt. Now acceleration along x is 0, so v along x is equals to u along x. In this, we'll take v along y is equals to u along y plus at. Now in this projectile, we have three things which we need to derive. So let me mention those things one by one. So first one is time of flight. Time of flight is nothing, just the time taken for the object to cover the entire trajectory, right? It's just total time taken by object to cover trajectory. Next, what we need to find is vertical height. Let me write the notations for them so it becomes easy for us to write. T, vertical height, height till which it reaches maximum height, yeah, maximum height till which it reaches. And third one is range, which we discussed this term. So horizontal displacement or distance. All right. So from this, along the y direction, we can derive the time of flight. Now u along y, initial velocity is u sine theta, and velocity along y will be 0. Okay, because at the highest point we are taking the highest point. Till the highest point, velocity along y is 0. So 0, wait, yeah, so 0 is equals to u along y, or u sine theta minus gt, since a along y is minus g. So u sine theta is equals to gt. So t becomes u sine theta by g. Now t is the time covered in half distance of the trajectory. Yes. So for the total time of flight, t will be 2t. So total time of flight becomes 2u sine theta by g. So this is questions through which we can find the total time covered during the entire trajectory. So yeah, so we got our first thing which we needed. Now for the next thing is vertical height. For the vertical height, we can use the formula of, yeah, we can use this equation, second equation, v square is equals to u square plus 2as. Now v along y, this is again 0. Yes. So v along y square minus u along y is u sine theta square into 2 into minus g. A along y is minus g into distance or vertical height, which you need to find. Now minus u square sine square theta is equals to minus 2g into vertical height. So the vertical height becomes u square sine square theta by 2g. This is our next derivation for the vertical height. Now next thing we need to find is the range. Now range is along the x direction. So for the range, we can just take the Stewart equation s, yes. So yeah, x is equals to ut plus half at square. Now s along x is u along xt plus, sorry, half at square. Now a along x is 0, so s along x is u along x into 2t. Now s along x become s along x, we can take s along x as range. Let sx be r. U along x is u cos theta into t. Now from above thing, we have t as uh, 2u sine theta by g. Okay, so t is total time of flight, total time taken during the entire trajectory, because t is during the half of the trajectory, and so we have to replace t with big T. So r is u cos theta into t for entire trajectory. This is just, and this was for half distance, half horizontal distance. So r is u cos theta into 2u sine theta by g, because we took this time of flight from this expression. So r becomes 2u sine theta cos theta by g. Now we have one identity from the trigonometry part of mathematics, which we'll do very soon. That sine 2 theta. Wait, let me write in different color. That sine 2 theta is 2 sine theta cos theta. Now we use this property to simplify this expression. So r is u sine 2 theta by g. Now this is how we found the range during this parabolic trajectory. And this is just a simple derivation for this parabolic projectile which we did, and for the horizontal projectile where we find everything similar to this. So in the conclusion we can write all the things which we found after deriving from this. Yes. So time is 2u sine theta by g. Second, vertical height is u square sine square theta by g, and range is u sine 2 theta by g. And you don't need to even memorize this. This is just when you need to do the questions very quickly or you need to solve them very fast. But if you get some structured question, then you can just do it using those SUAT equations which we used throughout the derivation in this. Yes, these are the base for this entire derivation which we did in the projectile motion. So that's it for today's video, in which we derived the horizontal projectile and parabolic projectile. In the next video, we'll do some certain problems on projectile motion. And if you like this video, please share, like, comment, and subscribe our channel. For any queries, you can always mail me, and comment on any topic you want us to make, and we shall get back with the video on our YouTube channel very soon. Thank you for watching the video. Stay tuned for the next video and come back. Thank you.